Just one more time. Today's the last day that I'll be with you all sharing. Thank you. So, 40 sketches, right? How'd that go? Anybody want to share something from that experience? Was it easier than you thought, harder than you thought? What's that? Took time. Was it coming up with the ideas is what took the time? Doing the sketching was the bottleneck? Doing the creative part? Is that how most people felt about it? Is the idea part is what was hard? Doing 40? Most people were nodding. You can nod this way if you disagree. Okay. Yeah, that's good. Was it? What about that was hard? Would you say the idea part? Just being creative, just thinking of something.
Finding a TV.
Finding a TV. You don't have a TV? Oh no. That's the first problem. Not having a TV. Okay. Other problems with the sketching? Idea part? So that part, coming up with the ideas really is a process that can be learned, you know? It seems like certain people are creative and certain people aren't creative. I don't think that's really true. I think you can learn to think in a more agile way, to sort of cross lines and move laterally around in different categories of products and solutions. I think you really can learn those skills. Sketching really is a means to an end, right? This is what Dr. Mon and I were just discussing. It's the bigger thing really is thinking creatively. It's solving problems when there are obstacles, and really that's the more interesting thing. You know, sketching really is just a small piece of that, and you can really learn that skill. And it's mostly iterative. You know, you practice it again and again. You practice thinking again and again. I recommend to people to carry a notebook with them. Just a small notebook you can put in your pocket. If you have your bag with you all the time, you can put it in there. But keep your blue pencil, keep your marker, but keep a notebook with you too, all the time, everywhere you are. I always have a notebook with me. You never know when you're going to get an idea about something. It could be crazy idea. Does anybody have a story of like some show that led to one of your sketches that was like a really kind of random connection? Did anybody have something really interesting happen? Could someone share an interesting story? Cartoons, soap operas. You're embarrassed to talk about what shows you watched. The Weather Channel, BTV. Is anybody on the dorms and have BTV? Okay, so what idea did you get off of BTV?
We have like 7 weather channels that just show the radar that goes around and around, which is really
Right.
But you're trying to pull things like the river or the highway or something that, I don't know, think of like the truck and how it works. And then from the weather channel, I went to thinking of like the hitch on a semi, which I don't know how that happened.
It's good, yeah.
Kind of like an idea, so.
It's good. So you never know when you're going to get kind of like struck with something, and so you practice doing that and you get a little more fluid at it. And I always leave it next to my bed too. Some of the best ideas come right before sleep or right when you wake up, and that's a whole other thing. But thank you for guys for doing that. So last week we talked about kind of 4 basic concepts of sketching, and I introduced you to my preference on tools. We talked about the value of lines, different line expressions, and some tricks for getting them to do what you want them to do. I gave you a super crash course on perspective drawing. Hope you gleaned a few things from that and practiced that a little bit on your own. And we talked about form and contour line compared to form line, and the Boolean operations that you use to build up larger things. So that's where we went, if you remember, last week. Today what I wanted to talk about was 2 more things, and that's context. Just really, I'll touch on that fairly briefly. And we'll talk about motion, animation, okay, in sketch form. Okay, so scale is an important thing. I should pull up these here. Right, so this is where we went last week. Right, remember, mashed potato gun. Okay. Splurm. You see a little guy down here doing his thing. We got some arrows there showing motion and kind of the sound effects. This was our truck, okay. There's a truck with a giant cannon on top of it. But it is hard to determine scale, so you've got this truck drawn, and you could do it. Let me just get this off here. You've got this little okay, and you're not sure. Here, we'll give it a big cool spoiler on the back. So we're just gonna rough this in here to get the idea across. Okay, so you've got this truck, right? And you are trying to explain this concept to somebody. Maybe you can't use words, and so you're trying to figure out context, okay? So how big is this truck, and how are you supposed to play with it? So you could draw a really large person here with a really large arm playing with that truck, and it looks really tiny. You could put in a much smaller person, and your truck looks a lot bigger, of course, okay? That's just what I mean by context. Whatever it is, you need to put that in perspective. Humanoid forms makes a lot of sense because most products you interact with, and so everybody right away gets what you're trying to do. You don't even have to really think about it. It almost seems silly to even have to talk about that, but sometimes your sketch out of context gets really confusing for people. So that's oftentimes the scale of the product, and you can do that with human forms. I think one I like to use is like other objects. I like to use an R2-D2 because I'm a geek like that, I guess. And so you put an R2-D2 in next to your little car form, and everybody gets, oh, that's R2-D2 and my little car. And you can put if you put an antenna like this on it, right, that'll help put it in scale, right? So, my product is, half of an R2-D2, 1/2 R2-D2. That's my scale, my units, okay? Or whatever. And then that gets fun because then you start talking about Star Wars in your brainstorming discussion, and it might lead to some interesting things, right? So, some kind of object that gives it scale is an important part of context. It's also how that object is used. So you might have a hand kind of on it. You might have a sketch of, let's say you've got like a remote control for this thing. You've got, somebody's kind of hands on that remote control, and we're going to talk about form in here, figure drawing forms in a second. So you can get the context across in that way. It's how you use it, it's how big the thing is, okay? So if you're drawing humanoid type forms, to get an idea of context, we're not going to go into like drawing people like really specifically because it's really time consuming. It gets kind of crosses lines into like illustration. I don't recommend you try to draw people that look like people. You just have to get some kind of a shape across so people understand what this thing generally looks like. So for instance, if you were to draw a human form, if you needed to do that for some reason, this is how I'd recommend doing that. And like I said, I'm not going to ask you to do it. I'll just show you really quick. You do it just like you would sketch anything, and it's a bunch of Boolean operations of simple geometric forms, right? So here's my person. And this is important. A human being, the average human being, is 8.5 heads high. Okay? All right? So that's way taller than most people think, right? Most people draw humans, they draw them too stumpy. So 8.5 heads high is important to remember, okay? So you've got this guy's head, and then you have his shoulders, and shoulders are circular. Your torso is larger circles, and your stomach, and your hips, and your legs, and your knees, right? You can build your entire body with a series of proportional shapes, right? You may have seen those figure drawing wooden sculptures that kind of have all the joints and look like this. And then you can just go in just like you would your sketch, you know, if you want to detail that a little bit, right? However you want to draw this guy. Or you can put clothes on him if you want, you know, for the kids. Or whatever, right? He's got clothes on. So your figure drawing is the same as your Boolean operations and everything else, but you know, like I said, I mean, if I'm doing 30-second sketches, I'm not going to draw figures in there. It's just not worth it. You sometimes need to draw hands up close, like this. You know how this pencil is being held, something like this. What I recommend when you need to draw a hand, there's not great shortcuts for drawing a hand. I recommend just using your other hand as a model. Okay. That is by far the easiest thing to do to draw a hand. And you just draw kind of what you see, and you try to get close. So if I've got a little toy car, I might find something that looks like a toy car, and I might have my hand kind of holding it in the angle I want, and I show what my hand looks like on the back of that car. I'm revving it up. I'm showing the revving action or something like that, okay? So that's how you would do that. If you had to draw hands, we're not going to go into that sort of thing. The way to rough a hand in is really simple. Small square, thumb, fingers, right? So from a distance, there's a hand. You have a long rectangle, slightly shorter, slightly fatter rectangle, and you get like the idea, all right, of a hand up in the air. If you wanted to go into that, and you can, you know, always add more stuff if you feel like it. Sometimes I'll find myself kind of just doodling around if I'm just feeling stale on ideas. I'll just kind of doodle on something else and refine it a little bit, okay? So you can go in there and make that more complicated, but very basic. Rectangle, thumb, fingers, all right? Rectangles. Okay, now, this is what you will really use much more often, and that's these kind of humanoid forms I'm referring to. This is how I recommend doing them. There's a lot of different ways to do this, and sketch artists kind of have their own techniques that they like to adopt. I do circle head, little kind of chubby body, really simple 2-segment arm. Okay? That gets the idea across, right? Everybody would look at that and say, that is a person who's interacting with a thing. That's the easiest, fastest way to get, in my opinion, to get a human into your sketch. He doesn't need legs most of the time. Unless, of course, your product involves using your legs, and then you have to find a way to draw some simple legs in there. I also like to do a 2-part line for his face. So, like his eye line. So here's a guy, for instance, let's say he's, I don't know, throwing my paper airplane design, you know, that I have. He's kind of looking up, and like that. And that shows how you throw that paper airplane. And then after he throws it, he's on follow through. All right, and he's looking down a little bit more. And his airplane is away. Okay. So that's like very simple to get across what's happening there. Does that make sense? I like this little eye line thing because you can kind of cheat a little bit. You don't have to draw a face, but it kind of just gets the rough idea across what's going on there. where that person is looking sometimes matters. Okay, a ball for a head, a short little potato body. 8.5 heads high. Okay, so that's humanoid type forms. That gives you scale, that gives you how you interact with the product, and we'll call that context. Okay, that's also pretty helpful, other than the product itself, how you interact with it. Okay, so let's talk about motion. Okay, so I brought this along. This is an example of one of the products that I did. Okay, Godzilla. He's fearsome. And this was Godzilla with tail whip action. Okay, look at that fierce tail whip action. Right here, I'll put it under this guy so you can see. Rawr. Okay, so this is a really interesting product. I bring this along. I ripped the rubber off the tail just to kind of show you how that works. Because it's this is where you start to bridge the gap from conceptual sketching to really some rough engineering. This tail is an interesting apparatus, the way this works. I built my prototype with a piece of Hot Wheels track and a bunch of straws. I cut into segments and glued down each side of the Hot Wheels track. I ran monofilament through them, and I could pull on one monofilament, and it showed an articulated bending and consequent stretching, and you pull the other monofilament, and it, of course, performs the corollary. And I could prove that concept with a piece of Hot Wheels track. It took me 10 minutes to build it with some duct tape. And then we start designing the product, and we get tighter and tighter refinement. This also uses an interesting manufacturing technique. I'll show you since we happen to be talking about it. If you're not familiar. Okay, this uses something called core slides. So you see the tail is made out of polyethylene, which is a really inexpensive plastic to manufacture. It's injection molded. There's a better view. But since I put the ribs offset, you see this on opposite sides, they're offset from each other. That allows me to put a piece of steel in my injection molded die from this direction and from this direction, and a piece of that steel kind of sticks in a little bit further. And then on the other side, you have a piece of steel that kind of touches right up against that tooth in between the ribs, and it creates holes. Can't see it very well there. It creates holes there. See those holes? Without having to have an expensive core slide that runs down like two steel rods into that tool once it closes to create those voids in the plastic when it's molded. Does that make sense? The expensive way to do this would be to take your two pieces of steel and close them, and then to slide two thin pieces of steel into the end of that, squirt in your plastic, wait for it to cool, slide out your two tines, open up your tool, and eject the part. But by using core shutoffs, tool shutoffs, you're getting the steel to touch one another, and where they touch, plastic won't flow. And so you can create the essence of a core slide and save the money in the tool manufacturing. So as I'm doing my sketching and my Hot Wheels track, I'm starting to kind of think about that. That might be a good idea to save some money in manufacturing. And we ended up carrying it all the way through on this product. And then you just go in there by hand and add these little ethylene ribs and rivet them onto the end with a hand operation. So inside his chest, you can probably imagine what's happening there. And this is what I had to try to convey to the rest of our engineering staff. So you end up with something like this, right? You've got Godzilla. That's terrible Godzilla, but you get the concept, right? And here's what this might look like. I show kind of a rough hand in there, and an arrow for moving his arm up and down. And I'm starting to rough in what this might look like. Okay, I've got what I know is probably going to be a PVC arm because it's going to be a solid material. And you can't do ABS that thick, it'll shrink awkward. I've got a little head on that because I know that I'm going to press that in to the socket in the side of his body. If I can create my part line right along that joint, I'm going to trap it as I glue the two halves of his torso together. And then inside I've got a standoff, and I might put like a slip gear in here with torsion spring against that to determine my slip, and and then that goes down here to, I might have one boss on the end of this other half of this slip gear, pulling one of my pieces of ribbing through his tail, and you go the other direction, it pulls the other way. So I'm starting to kind of sketch the engineering and what that might look like, and I'm sending it off. Here's the functionality I want. Here's my suggestion for how that works. My engineers look at it, they try a few things, they send me some prototypes of how that might work, and we play with it. Is this working? Are we getting enough motion from this tail? Is it strong enough to withstand some kid cranking on his arm? You know, does it perform the action that we want it to perform? And you know, it turns out to be very, looks very complicated with the tail on there. It's very animatronic. It's sort of a, in the industry, that's like a magical thing, right? That's where your engineering pays off. Magnets, for instance, are always going to be a big payoff with toys. They always seem like something magic is happening. You get this tail to curve around in very unique ways, not just a solid thing moving left to right. It seems kind of magical. There's something unique happening there. And that was the effect we're going for. We played back and forth with the engineering until we got that. So to get that concept across, I've got my sketch, I've got stages. Okay, I'm doing some motion designing. So in motion designing, you know, you just saw this one, right? Here's fearsome Godzilla and his arm in upward position. And, you know, if somebody else's hand on here, if I wanted to draw that, I'd draw my hand in here really rough. Okay, and I'd say, you know, we are grabbing that hand and we are pushing down. And then in stage 2, I'm going to show that that arm is gone into its down position, and it looks like this, right? So it's really rough, kind of dirty thing, but you can see we'll make him really angry. He's angry about his arm being pulled down, okay? Because he's Godzilla after all. And so it's really rudimentary, right? But I get the concept across. I might say A, and I might say B. And if I'm working with someone who speaks the same language, I might explain, in stage A, you know, grip the hand and push it down. In stage B, okay? Also, during this motion process, you're explaining sort of how your product works, how it moves. So arrows become really important. Okay, so we'll talk about that. Things like steps, A and B, or 1, 2, 3, okay, become really important. You have motion lines, right? I might show just simple lines like that, or I might do a real light version of this arm in a couple positions between these two, showing this thing can move. That's motion lines. It's really, oh yeah, this is also where you might do sound effects, right, at this stage, like I was talking about. This is, he's making the same sound as this truck for some reason. I'll save money, I'll use the same sound chip. Okay, Godzilla's voice is a truck, monster truck roaring, okay. You laugh, but, you know, we would do things like that sometimes. So, so this stage of animation is definitely more like cartooning in this process than it is like illustration. I've been saying that all along. The process of rapid visualization is more like cartooning, especially when you get to animating your product and what's really happening there. I think pantomiming helps a lot. The fact that I'm standing here in front of you and I can, especially if I have another one, right, I can pick up an action figure I've got sitting in the office and I can grab his arm and I can say, look guys, imagine if I did this on his arm, the tail would whip back and forth. And that's even faster than sketching it. I can say that in 5 seconds and you get exactly what I'm talking about. And someone across the table can say, oh yeah, let me see that. And they grab it and they say, what if you take his other arm and you do it and it makes his mouth move? And so now you've got these 2 things you can do, or someone gets an interesting idea. So the pantomiming process becomes really important in this collaborative process of design. Props also become really important. A good creative environment has a bunch of resources at their disposal. Whatever environment they're in that is the creative space should have a bunch of junk in it. You should have walls lined with toys if you're a toy design firm, or examples of products or pictures of products that are similar to what you're working on so you can grab things and talk about things. We had a person in our workplace whose full-time job was to purchase toys for us, okay? So I would say, hey, I played with this Spider-Man figure when I was like 10, and it has exactly the mechanism inside that I want to use for something. See if you can find it. And so like she spent like a week looking all over, found some antique Spider-Man somewhere, spent like $200 on it, got it delivered from Europe, and it shows up like Christmas morning, and I immediately take it to the bandsaw and cut it in half and pull out the mechanism, and I use that for another thing we were designing with Godzilla. In fact, that used a device called a windlass. which is a really cool device that's also magical. So basically you pull down on the cord out of the backpack of the grappling hook for this character, and he would ascend up the cord while pulling down. It's a very magical kind of, very simple two-part mechanism called a windlass. And so you look for kind of wins like that in toy design. It's inexpensive, but a cool payoff. So props are really important. Pantomiming is really important. Having lots of things around you. Standing while you're having those conversations is great, especially for the very intense, very exploratory, broadening type phases, where the gaps get wider, like we talked about 2 weeks ago. Having a low table or no table in the room so people can see each other's bodies and you can animate better. Actually, one of the companies I worked for, we took acting classes. They paid for all of our staff to take acting, improv classes, so you can express yourself more fluidly and have that conversation going, and that was interesting for the toy industry. So, okay, so pantomime, props, cartooning. So some techniques on that. It's pretty obvious, so I'll do them quickly, but you've got things like arrows, like I was just describing. You have up and down arrows. I find myself using this kind of an arrow a lot. Right, this shows this thing moves in a circle. And you follow your same principles of three-dimensional design that we talked about. What's happening there? And, right, so you got, get crank on the side of something, and, very clearly that crank is, designed to rotate in that kind of direction. You can do an arrow like, this, and, show that the direction for this is waving. You could do something like a staggered arrow. Right, and that shows that, maybe as you're pulling down on this lever, you're indexing, a gear that it's kind of clicking as you're pulling or something like that. You can be creative with that, but your arrows are tools for you. You treat them like objects, and they show all kinds of interesting motion. I mentioned steps. Just a quick hint on steps is I like to put them in these little, circles and make them pretty bold. So they don't look like part of your project. You have a little one floating out here in space, it doesn't really look like anything, And motion lines, like I was describing, really simple. It just shows this thing is vibrating, or shows whatever this thing is. You've got, two positions for it, up and down. This one's lighter, or something like that. It pivots around this section, And the sound effects, like I was describing, they're fun. They get people kind of talking, but it also really helps convey things. So I might say, on this staggered arrow, I might do click, click, click. And I want that to be critical. That's important to me, that the design is clicking at each thing, and then this says shwoom at the end. It finally takes off or something, right? So those are your tools for kind of motion and animation and things like that. Okay, so that's just some quick context motion things. I wanted to show you kind of how those things come together in my experience, and I'll try to do that really quick here. So this is my portfolio of one of the things that I worked on. This is that tree in the Children's Museum. Has anybody been to the 5th floor up by the carousel in Indianapolis? And there's like the big tree house up there. So I designed that tree house, and this was my first sketch for that. They basically said, we need something in the corner of this room. It's going to be a semi-permanent exhibit. And I said, maybe a tree house would be cool. It overlooks the whole space. It kind of feels like something you'd find by a carousel in a nice park somewhere. So we started with this sketch, and we thought hand puppets built into the trunk could be fun. Then I take it to this stage after a while where I kind of want to show some scale here with people. I add a little bit of color. I'm starting to Xerox it at this point because I'm doing multiple iterations of where the branches go, and I'm trying to save a lot of time. I do a 3-point perspective. We talked about this last week to show what it feels like for a child as you approach the entrance to that tree. I wanted to make sure that had the right experience, and so I make a low perspective. I'm starting to add thoughts and notes. A high perspective, if you could get up on this tree and see it from a different place. I really wanted children to be able to climb this tree because, you know, that's what you do with trees, right? If you're a kid, is you climb trees. And I presented that to the management of the museum. They're like, no way, we're not going to have kids climbing up on your tree. And so what we did is put a camera up in the top of the tree, multiple cameras, and you can control it with some joysticks down in the base of the tree. And you kind of feel like you're up on the top of the tree, and you can wave to your parents and things. So we started looking at what that perspective might be like. Here's a really quick sketch, right? I thought, what if there's woodpeckers on the side of the tree? But they're like kind of like a xylophone. So you flick their tail, and their beak vibrates against a tine in an echo chamber, and it makes kind of some sounds, and you can play these woodpeckers on the side of the tree. And so you can see I'm doing some very rudimentary kind of engineering concepts. This shows some concrete cast for the tree, maybe some bushings in trapping my tine in here. I knew I would need a strike surface. I knew I could treat his entire legs like a spring there, right? So I'm kind of starting to get a concept for the engineering staff to build this thing. And, you know, I did, who knows, 500, 600 different things like this for that one tree. Here's features we can add. We got it down to maybe a dozen or two in the final thing that made the most sense and were affordable and manufacturable. Here's some other sketches. You know, these ideas are old, but you just kind of get, here's adding some quick color and some shading to it. This was where I had to throw a hand in there to show the way that this particular product was compressing. This is interesting. This is using Rhino. Some of you have used Rhino, but it just shows the process from sketch to CAD sketch, right? Here's an aluminum extrusion project from sketch to CAD sketch really quickly. Here's throwing some hands and some color in to some Nerf guns. I don't think the designs are all that great, but you know, shows you some color and another way to go about that. This was kind of a Hot Wheels track thing that we were working on. I came up with this concept of using hexes for your intersections because it gave you a large variety of different things you could do with a very small piece of track. So the idea there, like I was talking about magic earlier, is large payoff, low engineering, low part count, okay? And so I'm creating permutations here of what that track could look like. This is just done on a Xerox machine. It's even faster than me sketching it. You know, there's some other blue lines I threw in there. I'll show you this one too really quick, just so you can see the whole process, okay? So here we start with blue line. This is like that caboodles type product I told you guys about that I worked on. So this had a large array of blue line sketches, okay? I mean, I did hundreds of these potential, how this thing could open or turn. You see my potential hinge concepts I'm working on there. Butterfly, using the body of the butterfly as the two-part hinge, and to be able to trap, you know, some things in there that you can use for, I don't know, decorating your fingernails or that sort of stuff. Here's a quick 3/4 sketch of how that thing might look. And I'm getting some ideas of some of the components. A quick engineering sketch again of how that latch might work. You can see I'm doing a kind of a hidden part there.